Okay, here's my awkward video for you for dilations for 2.5. This is because we are probably not going to have school on Thursday, so this is what we are doing in place of it. So you will need your notes, which I hope that you took home with you. If you did not, maybe just have a blank sheet of paper and a pencil and just kind of be jotting down some of the things that I'm saying and doing as we go through this. And just do your best to follow along. You can feel free to email me if you have any questions on this, but this is what we will be doing in place of class. So just go ahead and pay attention and do what you can and ignore any awkwardness that I have while I am teaching this to you. Okay, I do not like recording myself in the video, but here we go. Okay, so here is the warm-up. It says to graph these points to create a figure, so that's what you're gonna do. So it would be a good idea for you to just pause the video and try to graph these points without my guidance, and then come back in just a few seconds and see what it is supposed to look like, and then we're gonna talk about something else, okay? So graph these points to create the figure. Pause the video and do that, and then come back in just a second. Okay, if you have unpaused the video and you are here at this second, then you should have some sort of figure that looks like this on your graph or on your paper somehow, some way. But what the question here is, how would I take this and make it 2 times bigger? Now, obviously we can't have a discussion about this right now, but there are a couple different ways that you can think about taking this shape and making it 2 times bigger. So I want you to just think about that in your head for a second and decide what in the world does that mean to take this and make it 2 times bigger. When you think about taking something and making it 2 times bigger, hopefully the word times makes you think of multiplication, and in this case multiplying by 2. But what am I multiplying by 2? Am I multiplying the points by 2? Am I multiplying the side lengths by 2? Am I multiplying the area by 2? What am I doing? Okay, so I want to try all 3 of those, and I want to see what would happen in that case. Okay, so if I'm talking about area, I'm talking about all of the space inside of this particular shape, right? Well, lucky for us, there are squares inside of this, so it makes it kind of easy. So if you have this, then you would count all of the squares inside of that shape. There are 3, 6, 9, 12. Okay, so the area equals 12, right? If I take that and I make it 2 times bigger, I would take that area and multiply it by 2 to give me a shape that is now an area of 24, will be specific, units squared, okay? Units squared, so square units within this, right? Okay, that's if I make the area bigger. Now let's talk about the side lengths, right? If I have this current side length right here, and I count that, that's 1, 2, 3, 4, okay? That's a side length of 4. Okay, this one over here is also 1, 2, 3, 4, okay? Then I've got these side lengths here and here. This one is 1, 2, 3, and this one is also 1, 2, 3. So if I take those side lengths and I make them 2 times bigger, I'm gonna take this 4 and multiply it by 2. That gives me, I'm just going to draw it over here, 1, 2, 3, 4, 5, 6, 7, 8. Okay, a side length of 8. But now this top side length, okay, becomes 3 times 2, which is 6. So 1, 2, 3, 4, 5, 6. This one was 4 times 2, so that's 8. 1, 2, 3, 4, 5, 6, 7, 8. And then the bottom one of 3 also gets multiplied by 2. So that should be 6, 1, 2, 3, 4, 5, 6. So now what has happened, I don't know if you can see that well, we have taken that shape, okay, and given it a new new side length area that, or sorry, side lengths that have doubled, okay, or gotten 2 times bigger than what they were. And what you should see is a shape that is now 2 times bigger than it was before, okay? Now the other idea is, well, what if I took these ordered pairs that I have, and I multiply them by 2, okay? Well, let's see what happens. I'm gonna take -2 and 2 and multiply them by 2. -2 times 2 is -4. 2 times 2 is 4, okay? The next one, 1 times 2 is 2, and 2 times 2 is 4. 1 times 2 is 2. -2 times 2 is -4. -2 and -2 times 2 are both -4. Okay, if I did that, let's see what that would turn out like on the graph. Okay, so I'm going to plot those points. -4, 4. Then I've got 2, 4. Then I've got 2, -4, 1, 2, 3, 4. Okay, and -4, -4. So here. So what I see is this shape. Okay, and what do you notice? I know we can't have a discussion here, but it looks very similar to this, right? Let's count the side lengths. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. It's the same exact shape as this one, except in a different spot, okay? And this right here is where we're headed with this lesson, where we are trying to take some figure and dilate it, which is the name of our lesson here is dilations. Dilating is going to make something bigger or maybe even smaller in a very specific, particular way, okay? So there is a video that I'm gonna have you watch right now that I'm gonna get into that kind of describes these dilations to you. So instead of listening to me talk about it, you can listen to the video talk about it. So let me get that up here for you. All right.
Math shorts. Understanding dilations. In math, dilation refers to the process of making a polygon larger or smaller without changing its shape. It's picture day. Kate chooses a package with one photo for her parents, a larger one for her grandparents, and smaller photos for her friends. How can photographers print one photo in different sizes? Dilations. Dilation is where a two-dimensional shape grows or shrinks proportionally from a point called the center of dilation. Here we tripled the original rectangle, and here we divided it in half. In dilations, the dimensions and distances from the center of dilation stay in proportion. The center of dilation can be anywhere in, on, or outside of the shape. Scale factor determines how a shape grows or shrinks. If the scale factor is 3, the dimensions from the center of dilation are multiplied by 3.
This is important.
Different sizes, same proportions, same shape. A coordinate grid can help us see how this works. If the center of dilation is 0, 0, and the scale factor is 3, the horizontal distance from the center of dilation is 3, and the vertical distance is 4. Multiplied by a scale factor of 3, the horizontal difference becomes 9, and the vertical distance becomes 12, stretching the shape 9 units to the right of the center of dilation and 12 units up. Nice portrait, Kate. Grandma and Grandpa are so proud. If the scale factor is 1/2, the original dimensions are multiplied by 1/2. The dimensions of the reduced photo are 1.5 and 2. Different sizes, same proportions, with dilations.
All right, good. So this was just like a quick little video that describes really well what we are doing or what we are learning in this lesson, okay? So now is where you will really need your notes. If you don't already have them, please get them out. You should have been given those. I'm hoping that this doesn't look super blurry. To me, it looks like it's pretty decent. So let's talk about a dilation, okay? This is another kind of transformation that's happening in this chapter, okay? So a dilation, it says, is a transformation in which a figure is made larger or smaller, okay? So I really need to emphasize those words, larger or smaller, okay? That is a dilation. So something that we could reference to this is if you've ever had your eyes dilated, you would know that that's when you go to the eye doctor and they kind of dilate your pupils and your pupils get larger or smaller. Sometimes when I'm doing this lesson, I like to have you guys like awkwardly look at each other, and when you squeeze your eyes shut just like really tightly and then you open them really fast, your eyes, your pupils start to dilate based on the lighting that is in the room. And it's something that you can do in the mirror. You can go into the mirror and you can shut your eyes really, really tightly, but look really close at the mirror. And when you open your eyes, you can see your pupils dilating because they're adjusting to the light. So when there's not so much light in the room, your pupils are really big because they're open and they're trying to let in as much light as possible so that you can see your surroundings. But when there's a lot of light, your pupils kind of get really small because they don't need as much light to see what's going around you because there is already so much. So it kind of dials that down for you so that you aren't blinded so much by what's going on, okay? So your pupils dilate, and that's kind of something that relates to what we're doing here. They enlarge or they reduce or they get larger or smaller around a certain point called the center of dilation. Now our center of dilation, please write this, is 0, 0. Okay, we are dilating with respect to that origin, that center point on the graph, okay? In a dilation, the angles of the image and the original figure are congruent. That just means that in my original shape, if I've got something like this is 90 degrees, okay? When I dilate it, it's still 90 degrees. Now, it's not necessarily 90, it could be anything, okay? I could have a triangle with like a 50-degree angle or something, but when I dilate it, it should still be the same angle. Congruent just means equal, okay? It means they're still the same, equal, all right? One of the things that it mentions over here off to the side is that a scale drawing is an example of a dilation. So something that is relative to this, I guess, is think about a blueprint. Okay, a blueprint is a scale drawing of a house, a building, some sort of something that's going to be built, but it is not drawn in the actual scale of what it is that's going to be built. I mean, could you imagine even just the blueprint of this? The paper would literally be the size of this, and that's ridiculous. We don't need something that size. We could take this and shrink it down and write it on a piece of paper and say the dimensions will be, 5 feet by 4 feet or something, rather than actually drawing it that big on a piece of paper. Okay, that's silly. So that's a scale drawing. Another one could be a map, okay? Just think about a map. Oftentimes on a map it will give you something, I think called a key or a legend, and it will tell you how much some small portion of that map is actually in real life. So it might say like an inch on the map represents, 50 miles or something in real life, okay? Probably something more than that, but that's what's happening there. So it's a scale drawing, it represents a dilation, it's a smaller portion of what the true item actually is. Okay. All right, so identifying a dilation. Tell whether the blue figure is a dilation of the red figure. And something, again, to note is that a dilation is not just something that gets larger, it's also something that can get smaller. So we are looking at from red to blue, does it look like the same shape that has been enlarged or reduced or bigger or smaller, okay? So if we take a look at that red shape, okay, does it look like this has been dilated? Does it look like it's been made smaller or larger? Okay. If you look at it, it's telling you that the angles should still be the same. Okay, so this angle should still be the same as this angle. This one should be the same as this one the same as this one. That's what it told us before, that they are congruent. Okay, but if we look at it, does it look like this has just been kind of dialed down, shrunk down to become the new one? Hopefully in your mind, you're saying yes, or hopefully you've shouted it at me like 17 times already, Miss Orange, yes, 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 yes. Okay, the answer is yes. But then if you take a look at the next one, what we notice is that yes, the angles are the same, okay, but it hasn't gotten bigger or smaller, okay? If I take this and I place it on top of this, they should be the same exact size. What we've learned, hopefully, is that this is a translation, okay? This has just been slid, okay? So this one is no, but you could note that this is a translation, okay? This is a slide, so remember that. Okay? I would say, do you have any questions? But at this point, you can't really ask me any questions, so I'm so sorry. All right, the next thing, same idea, okay? Tell whether the blue figure is a dilation of the red. So go ahead and do that on your own. Kind of decide, is that yes or a no? And then I will write the answer in just a second. Okay, the first one, I hope that you are saying it's a no. Okay, this one is no. One thing that you should note is that this looks like it has been flipped, and it has, okay? This is a reflection across that y-axis, so you could say it's a reflection. All right, but then if we look at the next one, tell whether the blue is a dilation of the red. So the blue came from the red, what happened? Okay, it does look like it's bigger. It looks like the same shape. It looks like they still have the same angles, okay? So this one is a yes. This is a dilation, okay? This part right here is, the wording is a little advanced, okay? But in a dilation, the value of the ratio of the side lengths of the image, the new one, okay, to the corresponding side lengths, meaning the same side lengths of the original, okay, is the scale factor. Now let me break this down for you, okay? The value of the ratio. So let's say, for example, that this side length is 2, okay? And this side length is, let's just go with 4, okay? The ratio of those side lengths, the ratio is 2 to 4, okay? 2 to 4. The original one, okay, is the red. This, I'm looking at this top side length, I'm telling you that it's 2. The corresponding side length is the top one on the other shape, okay? So that's the corresponding one. 2 corresponds to the 4. This is the ratio of the 2, okay? And what they're saying here is the value of that, okay, is the scale factor. To find the value of a ratio, you will divide, okay, the new one by the old one. So I should have written it the other way around, the new to the old. So I'm going to flip that around. The new side length is 4. The old side length is 2. And to find this scale factor, okay, we find the value of this ratio. Now this is something that the 7th grade honors class is learning currently. They're learning how to find the value of a ratio. This is something that you should have done in a previous year's class, but I'm going to tell you, to find the value, you can just look at this as if it's a division symbol. You're doing 4 divided by 2. 4 divided by 2 is 2. Now they're telling us that the scale factor is that answer, okay? That just means that what I did was I took this and scaled it by 2. This is 2 times, in this case, larger, 2 times larger than it was before, okay? So all of that to just say, we kind of create a ratio of the new to the old, okay? And that gives us the scale factor, and we'll get more into that within this lesson, okay? So don't think too much on that right now. Okay, this is where some of that stuff comes in. So we've got dilations in a coordinate plane. To dilate a figure with respect to the origin, so just kind of from the origin out, the coordinates of each vertex, remember the vertex are just the points, so multiply, that's kind of bolded there for you, each point by the scale factor. Now, scale factor is always represented with the letter K, so the question might say something like, dilate when K equals 5, okay? Now that just means take every single point and multiply by 5 if k is 5 or the scale factor is 5. But there are some specifics about this. Take a look at the algebra. Okay, here's the rule. X, y, this is on your paper, becomes kx and ky. Now that seems a little bit confusing, but they just told you that k represents the scale factor. Okay, so maybe they give us a point like 2, 1, okay? That's our point. And they might say that k, that the scale factor is 3. Now what this is saying, remember when we have a variable next to a number or something like that, this means multiplication. So what's happening is kx means k times x, and ky means k times y. So we're taking whatever our x and y are and multiplying them by k, the scale factor. So let's say the scale factor here is 3, okay? I'm gonna do 2 times 3 and 1 times 3, okay? That's the math behind it, to get my new point of 6, 3. So the dilated point, 2, 1, 3 times larger is 6, 3. Okay, so that's what's happening here. We're just taking every single x and y and multiplying it by the scale factor. Now, here's where it's important. When the scale factor is greater than 1, that represents an enlargement, okay? Greater than 1, it gets bigger, okay? Greater than 1 gets bigger, greater than 1 gets bigger. Now, if it's between 0 and 1, so less than 1, okay, it's a reduction. So greater than 1, larger. Less than 1, smaller, okay? That's what this is saying. Now we can't have a negative scale factor, so that's why it's saying it's between 0 and 1, but anytime it's a fraction or a decimal between 0 and 1, it will get smaller, okay? It will get smaller, sorry, less than 1. If it's 1, it stays the same, okay? So let's get into some of that stuff. This off to the side is just showing you what's happening. They're taking all of these points and they're dilating it so it gets much bigger in this case. Okay, that's an enlargement. So that scale factor must have been greater than 1. But if we went from this one down to this one, that's a reduction, okay? And that means that the scale factor must have been less than 1, okay? All right, yeah. So let's try it, okay? We're given some points. It's already showing you that on the graph, but we're gonna do the math here in this box. So the vertices of a triangle are A, B, and C, okay? Draw the image, remember that's the new one, after a dilation with a scale factor of 3, okay? Identify the type of dilation. So here, when it says identify the type of dilation, there are 2. A reduction, or a getting smaller, or an enlargement, getting larger. Okay, but we use those kind of more technical terms, enlargement or reduction, okay? So, the vertices of a triangle, we'll start with that. A, B, and C. A, B, and C, okay? A is 1, 3. B is 2, 3. And C is 2, 1. The rule for dilations, okay, is to multiply each x and each y by the scale factor. So we take our original x, y, okay, and the rule says kx and ky. Remember that that means multiplication. Whatever the scale factor is, in this case, k equals 3. So we're going to take all of the x's and multiply by 3, and all of the y's and multiply by 3. And that gives us our answer, okay? So let's do that. My first one here for A prime is going to be 3 times 1 and 3 times 3. Okay, and I'll get my overall A prime point, which is 3 times 1 is 3, and 3 times 3 is 9. This is my new point, okay? Next one, B prime. I'm gonna follow the rules. So k times x, in this case, k is 3, or the scale factor is 3, times 2, and 3 times 3 gives me a new B prime point of 6, 9. Okay, and then the last point, C prime. I've got my scale factor times x, so 3 times 2, sorry, and scale factor times y, 3 times 1, which is a new point of 6, 3. Okay, and then we see that graphed over here. So the original points, 1, 3, 2, 3, and 3, 1. Here's the original shape. Are going to get dilated. So we're starting here, and it's as if we are growing from that center point right here. Okay, I'm not like sliding it this way or sliding it downwards. I'm starting here, and I'm just enlarging it this direction. Okay, and I did just say enlarge. So since the scale factor is 3, okay, is greater than 1. Okay, if it's greater than 1, that is an enlargement. It gets bigger, okay? Take a look at those new points. I've got 3, 9, 6, 9, and 6, 3. Okay, if we connect those, we see the new one looks like this. Okay, it told me to multiply by 3, so this tiny triangle here got 3 times larger. That's an enlargement, okay? So we dilated it with a scale factor of 3, okay? I multiplied all of those points by the scale factor of 3. I got my new points, which got bigger. That's an enlargement. So the type of dilation, enlargement, okay? I hope that you don't have any questions. This is a pretty straightforward concept. It's just getting the math right when you're multiplying, okay? So I think there's another one here for us to try. Okay, so what if ABC is dilated by a scale factor of 2? What are the coordinates of the image? Give me a second to just go back and write down those points. 1, 3, 2, 3, 2, 1. 1, 3, 2, 3, 2, 1. Okay, A, B, and C. Hopefully I just copied those down right. So same questions as, same points as before, but now they're giving us a new scale factor. So what I want you to do right now is the same exact math that we just did in the previous question, where we took every single one of these points and figured out what that rule was and got the new ones, okay? So here, in between, what I want to see is the math. And then over here, I want to see A prime, B prime, C prime, after dilating with a scale factor of 2, okay? Please, please, please pause the video. Don't just wait for me to give you the answer, okay? Be honest, be trying it on your own, pause it, and then go through and see what the answer is, okay? All right, so if you're coming back then from pausing, you should be multiplying every single point by 2. So we've got 1 times 2 and 3 times 2. Then we've got 2 times 2 and 3 times 2. And then we've got another 2 times 2 and 1 times 2. And we get our new points. 1 times 2 is 2. 3 times 2 is 6. 2 times 2 is 4. 3 times 2 is 6. 2 times 2 is 4. And 1 times 2 is 2. So if I was to graph this, okay, my original points 1, 3. So let's say I go over 1, up 3, okay. And then 2, 3, and 2, 1. So the original one was something like this, okay? And then I have my new one, so 2, 4, 5, 6, 2, 6, 4, 6, 2, 3, 4, 6, and 4, 2. So here is my new one that is about 2 times larger than it was before. We have a scale factor of 2. Okay, K is greater than 2. So this again is an enlargement because when that scale factor is greater than 1, it gets bigger. Okay? So then let's look at another example here. Okay, the vertices of a rectangle are W, X, Y, and Z. Draw the image, the new one, after a dilation with a scale factor of 0.5 and identify the type of dilation. Okay, so this involves some math and some thinking here, okay? So let's start with the original points, okay? We've got W, X, Y, and Z in our original points. Okay, the first one is -4, -6. So we're just copying these straight down from the question. Then we've got -4, 8. Okay, then we have 4, 8, and 4, -6. This question says draw the image, okay, after a dilation with a scale factor of 0.5. It's already drawn over there for us, but we're doing the math behind all of this, okay? So the rule says to multiply each x and each y by the scale factor of 0.5. Okay, now let's talk about that scale factor for a second. If we went back to the notes section, where in that box it said when k is greater than 1, it's this. When k is greater than 0 but less than 1, it's this. Let's talk about this scale factor, 0.5. Okay, this is a scale factor that is less than 1, right? So k is greater than 0, but less than 1. When it's in between those two, this right here is a reduction. So what we should see in our graph is that it gets smaller, okay? Now we need to do the math, okay? So we're gonna take every single one of those points and multiply by 0.5, okay? I'm hoping though that you would know that 0.5 is the same as 1/2, because it's a lot easier to multiply something by 1/2 than it is to multiply by 0.5, I think. So let's talk about it, okay? I'm gonna take this -4 and multiply by 1/2, and -6 and multiply by 1/2, and that's gonna give me my new W prime, okay? I'm gonna do the math over here. So if I do -4 times 1/2, I know you can't answer me here, but I want you to think about how do you multiply a whole number by a fraction? Okay, this would be to put the whole number over 1, and then you multiply straight across. So -4 times 1 is -4, and 1 times 2 is 2. Okay, -4 over 2 is the same as -4 divided by 2, which is -2. So the new point here is -2. We're going to do the same thing with -6, okay? -6 times 1/2. How do you multiply a whole number by a fraction? Put the whole number over 1 and multiply straight across. So -6 times 1 is -6. 1 times 2 is 2. -6 over 2 is the same as -6 divided by 2, which is -3. Okay, so that point there is -2, -3. Now notice, how does that compare to the original point? We went from -4, -6 to -2, -3. The scale factor is 0.5, which we just said is half. So you should notice that these new points are half the amount of the other points, okay? Or the original points. So the same idea applies to all of these other points here, okay? So what we have is another -4 times 1/2 and 8 times 1/2. Okay, when you are multiplying by 1/2, it's the same thing as saying what is half of this number, okay? So in this case, this x prime, okay, the new point there, half of -4 is -2, and half of 8 is 4, okay? You could go through and do this math again, that's totally fine, but this is just saying what is half of each of these numbers, okay? So the next one, we've got 4 times 1/2 and 8 times 1/2. I do want to see you writing out this math. You will have to do it on the quiz or test. Okay, y prime is now half of 4, whoops, sorry, half of 4, which is 2, and half of 8, which is 4. Okay, and then z, we're going to do 4 times 1/2 again, and -6 times 1/2, and then we'll get our z prime. So half of 4 is 2, and half of -6 is -3, okay? So we take a look at those original points versus the new ones, okay? The original ones are here, So W is that -4, -6. Okay, each of these lines represents 2. It's counting 2, 4, 6, 8, 2, 4, 6, 8. Okay, then we've got -4, 8, then 4, 8, and then 4, -6. Those are the original ones. But once I take that and I scale it by 0.5, I've taken that and cut it in half. I've made it half the size that it was before, okay? So what I have here is, my new point, -2, -3. Notice that that's halfway between because this line is 2 and this line is 4, but we've got it at 3, so it's between the two, okay? And then -2, 4, 2, 4, and 2, -3. Okay, so here's the new one, whoops. The new one is half the size of the old figure, okay? One of the other things that you could note here is that the side lengths, if they are nice and straight lines, they should do the same thing as well, okay? Like we did in that warm-up question. So this side length right here is 4. And if I'm cutting that in half, then the new side length is 2, which it is, okay? This one is 1, 2, 3, 4, 5, 6, 7, okay? And the new one should be about the same, half of that, which it's kind of hard to tell here in these lines, but it should be about the same. 1, 2, 3, 4, 5, 6, 7, yeah, about half of that, okay? 1, 2, 3, and then it's in the middle, so half, okay? Sorry. All right, let's look at the next one, which I think is another try it, okay? So taking those same points and scaling them by 1/4, okay? So this is making it 1/4 of the size that it was before. So we need those original points. Give me a second to write those down so that I can transfer them over to the next slide. Okay. All right. Okay, so same idea. And something I didn't mention, I guess, in the previous question, maybe I did, I just didn't really clarify, that when you are multiplying by 1/2, it is the same thing as dividing by 2, okay? So a similar idea happens here when we're talking about 1/4, okay? So we've got our original points, W, X, Y, and Z. -4, -6, -4, 8, 4, 8, and 4, -6. So if you don't have those written, go ahead and write those down, okay, because we will be changing those. I'm gonna make sure that this is still recording. All right, so then what do? We dilate it with a scale factor of 1/4. Now we need to figure out what's going to happen with this scale factor, okay? We're multiplying everything, okay, by 1/4, multiply by 1/4. This scale factor is greater than 0, but less than 1. So when it's greater than 0 and less than 1, this is a reduction. So it should get smaller, which means all of these numbers should get smaller, okay? So we need to figure out what's going to happen here, okay? So I need to take every single one of these and multiply by 1/4. Now it does say to try it, so I think that you should try it. And remember what I just said, that when we are multiplying by 1/4, this is the same as dividing by 4, okay? Multiplying by 1/2 is the same thing as dividing by 2, okay? So just think about that for a second, but please actually try right now, pause the video and see what you can come up with these questions, okay? And then come back in a minute and check your answers. Okay, so if you have come back from trying it on your own, these are the answers, so you can go ahead and check that and see if you got it right. Maybe circle this, star this if you have questions about it. If you don't quite understand how those answers came about, then you can talk with me and we can go over it, okay? Okay, so at this point it's the homework, all right? The homework is already posted to Big Ideas, so you could go ahead and try to do this. However, I think that we had intended on maybe trying to save this homework for Monday when we come back. So I would say you could try it if you want to, or just save it for Monday. And then if not, we will spend some extra time reviewing or doing some IXL or some other activity. We do have a fun activity coming up for you where you are going to dilate your names. You'll be graphing the letters and then dilating them based on what it says, and then making it look pretty cool. So for now, that is dilations. That is it. So if you need extra practice, you can email me and I can help you out with that. See me for help class, all of the things. But that's it. Okay, I know it was a long video, so just relax now. Okay, all right.